All right, so let's go ahead and try this section 4.3 rotation. So a rotation is a transformation in which a figure is turned about a fixed point called the center of rotation. Rays drawn from the center of rotation to a point and its image form the angle of rotation. A rotation about a point P through an angle of x degrees maps every point Q in the plane to a point Q prime so that one of the following properties is true. If Q is not the center of rotation P, then Q P is equal to Q prime P, and the measure of angle Q P Q prime is equal to x degrees, or if Q is the center of the rotation, then Q is equal to Q prime. All right. So the figure above shows a 40 degrees counterclockwise rotation. Rotations can be clockwise and counterclockwise, but in this chapter, all rotations are counterclockwise. So remember that all rotations are counterclockwise unless otherwise noted. So again, same thing. They have certain rules here. I'm going to try to show you something. If it doesn't work, follow the rules. So a rotation of 90 degrees, A and B, becomes a negative B and A. A rotation of 180 degrees, A and B becomes negative A and negative B. And then for a rotation of 270 degrees, A and B maps, remember the arrow means maps, to B and negative A. So example 2, and again, I accidentally took the one that is the example in the textbook, so hopefully this will help you see it a little bit. So graph quadrilateral RSTU with vertices R is 3 and 1, S is 5 and 1, and T is 5 and 3, and U is 2 and negative 1, and its image after a 270 degrees rotation about the origin. So I want you to think here. Now I'm going to use S for you so we can kind of see. And I'm going to put it up to the camera up here. So follow me carefully, okay? So if we look here, and remember I told you that I put a red square in the rotation here. So now I have to remember if I can do this right. So right now it's in quadrant 1. If I do a 90 degrees rotation, now notice it is in quadrant 2. All right. If I do another 90 degrees rotation or 180 degrees, it is now in quadrant 3. All right. And if I do one more rotation, again, watch where that red one was. Remember, I was clear up at the top. If I do one more, all right, it is now in quadrant 4. So now, remember, my point was at 5 and 1, and now I want you to see where it's at. So if I don't have everything else, can you count to where it is? Now, it looks like that purple point there is at 1 and negative 5. All right. So then you would pretend you're back at the origin. All right. You're back at the origin. And and so when you're back at the origin, you're going to take your point there. And remember, I just told you that point was where? At 1 and negative 5. So our S there now comes down here, which is our S prime. And I just told you it was at 1 and negative 5. So does it follow the rotation there? So again, my S, which was at 5 and 1, mapped to S prime, which was 1 and negative 5. So if we look here, it did follow the rule good. All right. So now I want you to kind of think the same thing. So if I did the 1, the 3 and the 1, so let's just go ahead and, again, if you can see the rotation, take a piece of graph paper and do that. If not, use the rules there. Okay, so if I take R, which is at 3 and 1, remember, it's going to tell us we're going to make R prime be at 1, and then I'm going to take my 3 and I'm going to negate that. All right, so S is going to be at 1 and negative 1, 2, and 3. So that one right there is R prime, and that is at 1 and negative 3. All right, so the same thing here. Let me see. What do we have? U is at 2 and negative 1. So again, I'm going to take U prime. And again, it doesn't matter what order you do the points, ladies and gentlemen, especially if you use the rule or even if you rotate it. So we're going to what? We're going to keep B the same and just put it in the other one. And then we're going to negate the other one. So we should be at 1 and negative 2. So U prime is at 1 and negative 2. And then finally, what's the last one? T is at 5 and negative 3. So it'll go to negative 3, negative 5. And again, connect the dots. Oh, I forgot to connect the dots on the first one there, didn't I? All right, well, that's easy to fix. Should have connected the dots. I got so excited showing you how to use it. So remember, on the video here, ladies and gentlemen, you can stop it and pause and rethink it through. All right, so that's that one right there. Okay, so then because of rotation, remember, rigid motion, I told you earlier, does not change. All right, it does not change its size or its shape. Its angles stay the same also. So because of rotation is also a rigid motion, you can use it with other rigid motions like translations and reflections. So example 2 here, because of rotation is graph line segment RS with endpoints at R at 1 and negative 3. So 1 and negative 3. There's my R. And my S is at 2 and negative 6. And let me move it up a little bit for you. And again, that is my S. And we're going to rotate it 180 degrees. So remember, the last time I showed you, when they give us the order, we do it in that order. All right? So I want you to think about rotating it, or if you're not sure about the rotation, all right? I know I'm going to go 90 degrees will go to here, 180 would go to here, all right? So again, let's go ahead and write it down in case we need to, all right? So our R, which is at 1 and negative 3, and our S is at 2 and negative 6. If you need to use the ones up here, okay, it tells me I negated both of them. So our rotation, let me write the rule for you here real quick, is AB goes to negative A, negative B. All right. So again, if I rotated it like I just showed you with the last one, you can still see the same thing. But if you're not seeing those, our R was at 1 and negative 3. So it tells us our prime here will be at -1 and a -3 or +3. All right. And our S, we would go from 2 to -6. Again, we're going to take S prime, we're going to negate it, which will be -2 and a -6 or +6. So let's go ahead and draw that one. So I said at -1 and 3. And that's my R prime. And my S, I said, was at -2 and 6. 1, 2. All right, and again, we're going to draw that. So now remember, that's only the first one, so we still have to do the reflection. So remember, the reflection now, it's over the y-axis. So if we look at the y-axis, this here's our y-axis, right? This one here is our y-axis, all right? So again, remember on that, and I'll go with my green like I did last time. I'm going to go 1, 2 to get to the y-axis. So I'm going to go 1, 2 to get to the other one. So, oops, it looks like my R is going to get in the way there. So let me change that real quick. So R was at, prime is at -1 and 3. Now I can erase it over here because that's going to be in the way. And let's see here. So on that one there, when I move it, if I move it 1 to the y-axis, I'm going to move it 1 there. And let's see here. Why don't I make that one be orange? So my R double prime, where is it? It's at 1 and 3. And my S double prime is at, now it's at 2 and 6. And again, I'm going to make that. Okay, so again, I hope it's pretty straightforward on there. And the last ones here are identifying rotational symmetry. A figure in the plane has rotational symmetry when the figure can be mapped onto itself by a rotation of 180 degrees or less about the center of the figure. All right, this point is the center of symmetry. Note that the rotation can be either clockwise or counterclockwise. For example, the figure below has rotational symmetry because a rotation of either 90 degrees or 180 degrees maps the figure onto itself. So kind of look where they have that little line right there. All right, they're kind of showing you what they're doing. All right, so 90 and 180 degrees will map it onto itself. And then they're showing you that a 45-degree rotation does not. So, example 4, does the figure have rotational symmetry? If so, describe any rotations that map the figure onto itself. So, like we just learned the other day, I can take and I can go through the vertex here and go to the midpoint of the other side. If I go from the vertex here, I can go from this vertex to the midpoint of the other side. And then same on this one here. I can go from this vertex to the midpoint of the other side. All right. Now, an easy way to remember it is how many lines did I draw? I drew 3. But again, you have to picture yourself rotating it. All right. So if I rotate this one here, just this part here, it's not going to do anything, all right? But if I rotate it all the way to here, then this point right here is now at this point here, all right? So I can go again this way here, all right? So if I do that, my point that was there is now there, and then finally I can do this, and I get back to my original point. So if you think about it there, ladies and gentlemen, kind of what did I just make there? I kind of made a circle. And how many arrows did I just show you? I just showed you 1, 2, 3. So an easy way to think about it is, yes, it does have rotational symmetry. All right, we know that a circle is 360 degrees, and I just showed you 3 arrows. All right, so 360 divided by 3 will give you 120 degrees rotational symmetry. All right, number 2, I'll tell you again, if we tried to do this one here to this line here, well, it's not going to be the same as this one here. So you can already tell that one should be no. All right, but now on this one here, remember, if I draw a line here, okay, that one will work. All right. Let's see, can I do any more lines of symmetry? Well, it looks like I can do this one here. Now again, this is just lines of symmetry that we learned just the other day, right? Remember, I told you I didn't put it on the notes, but I showed it to you. And then this one right here would be the same. But so it has 3 lines of symmetry. But again, if I take this point right here, and I should have used yellow, I do apologize. So I'll just use orange there. Now I want you to think, if I go to this point right here, is it going to be the same? And you're going to tell me no. If I go here, is it going to be the same? And you're going to tell me no. But if I go all the way here, it's going to look like its original shape. So if it's going to look like its original shape there, well, there's one time. Again, if you think about it, then the only other way it'll do it is right there, and that'll be 2 times. So does it have rotational symmetry? And you would tell me yes. I really wish they would have not put that thing which makes me close it there on the left-hand side, because us left-handers work kind of a little different. So I'm going to say 360 divided by 2 this time, because I only have 2 arrows, right? So that would be 360 is divided by 2 is 180. So this one will have 180 degrees rotational symmetry, which again is different than line symmetry. All right, so again, I showed you 2 things. Remember, I showed you up here how to rotate it, and it's kind of funny because I actually had to rotate it in the opposite direction because this is a mirror for me too. So I hope that helped you on this one. So now you should be able to do the worksheet. All right, and good luck.